Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good morning. Today we continue our class with the chapter 12 with the working drawing. Yeah. The topic is introduction, detailed drawing, assemble, drawing, assemble section, and dimensioning. Okay, we go to definition first. Yeah, working drawing is a set of drawing used during the work of making a product. Yeah, the keyword here is making a product. Working drawing is divided by two. Yeah, the first is detailed drawing, and another one is assembled drawing. Yeah, you need to understand both. That is how you detail up of your drawing, and how the assembly process. Yeah, this is important. Somehow in our drawing, in our design, yeah, we did not check yet. Is it our design is have assemble ability? Yeah, somehow, yeah, you develop your product with very nice design. However, you forgot about uh, assemble. Yeah, assemble ability. Yeah, then after that you face another problem, then you come to assemble. That is become the big problem. Yeah, on this one, detail is okay as long as the drawing is readable. Yeah, all the information can be transferable. Okay, that is make it the easy. Yeah, that is enough. But in the assemble, yeah, the assemble ability, you can't. Yeah, you can't do that. You need to check, is it possible to assemble one by one all the parts? If not, you need to change. Assemble drawing, you can tell your client, yeah, the process, the assemble. Okay, that is another function. Yeah, if you buy something, there is a figure. Okay, that is to show you how to assemble. Yeah, that is another function. Detailed drawing is multi-view representation of single parts with dimensional dimensional. Assemble drawing is drawing of various parts. Yeah, part of the machine or structure assembled in their relative working position. The purpose. Detailed drawing is convey the information and the instruction for manufacturing part. Assembled drawing is convey. First is complete shape of the product. Yeah. Second, overall dimension. Third is relative position of each part. Four is functional relationship among various components. Yeah. We go for detailed drawing. Information in detailed drawing. First, general information is title block. Second is part information. First is shape description, size description. Yeah, that is we turn become object view. Third is specification. You can put any notes. Yeah, in your drawing we can put any notes. Yeah. General information. There is name of company, title of drawing, usually part name. Okay. Drawing sheet numbers, name of drafters, checker, and finals. Yeah, that is another step of the drawing. And another one, relevant date of the action. That is drawn, yeah, when, and the check and the approve. Yeah, and there is revision table. Yeah, and unit scale method of projection. Yeah, then we focus with the unit scale and method projection. I will highlight another one is revision table. This one important. Yeah, that is as a record. Once you have developed something or develop a product, that is you will face another problem. Yeah, you design, after that you go to analyze, then there is something, yeah, maybe from the analysis there is failure in the parts, yeah, then you need to upgrade the drawing. Yeah, you need to upgrade the drawing, then the drawing you need to revision, you go again to the drawing, then you go for the revision. Okay, that is actually as a record. Yeah, as a record, that is various function, yeah, or objective. Let's say for example you develop something, a product. Yeah, you have the revision table, actually revision table actually as a record. Yeah, design changing, yeah, one by one. Okay, that is record. Once you register to the authority, they will have checked everything. There is a case, let's say, yeah, there is filer later, then they will check everything from the analysis, why you change this, why you change, blah, 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 everything. They will check in detail. Yeah, that is good. There is a revision table. Any drawing, any changing, yeah, you need to revision table. It's not only that actually for your record, for your safety. Let's say during the there is something happen to the product, then the authority can check detail product. Okay, shape or graphic drawing, pictorial drawing. There is a size, dimensions, and tolerance. Specification, part numbers, name, numbers required, type of material used, general notes, heat treatment if if there is a heat treatment to in the your material, surface finish, general tolerance, you can give general tolerance. So mean all the product you give that tolerance. You give the tolerance. But also you can give specific tolerance. Okay? Recommended practice. Draw one part to one sheet of the paper. That is rule of thumb. Draw one part to one sheet of the paper. Please don't draw more than one part in the one piece of the paper. Second is, if not the case, apply enough spacing between the parts. Draw all the parts using the same scale. Otherwise, the scale should be clearly noted under each part drawing. But is not recommended. Better, the best thing, draw one part to one sheet of paper. Standard parts such as bolt, nut, pin, bearing do not require detailed drawing. Okay, even though there is none on the detailed drawing, there is no drawing for bolt, there is no drawing for the nut, but there is information in table, okay, in the assemble, or the exploded view, let's say, you have all the parts, then you can give a note. This is bearing with the specific classification, but it's not a detailed drawing. No need, because that one is standard part. Okay, placing the information, completed drawing in the center here. You can check. You have a template in the CAD system later. That is part numbers, part name, material numbers, number required, load, unit, filler, run, size, and etc. That is a template. Detail. There is a detail. You can check later. Example. This is one example of a detailed drawing. You have two views here. Okay, you have all the drawing here. You have all the information here. Here, that one. There is a scale. Then date, let's say, who the draw. Okay, who will check and give improvement. There is a numbers, numbers of drawing. Okay, you need to give a numbers of the drawing. That is easy to track with page. This is if you have the changing, let's say the revision one by one, you can put it as the information. That one is orthographic view. Dimensioning and tolerance. Surface finish, if you have, this is one of the surface finish. Okay. general note, yeah, unless otherwise specified. Surface finish, that is, okay, that is not the note. Title block, yeah, this one or title block, okay. Revision, general tolerance, yeah. Projection. Okay, we go to assembly drawing. Type of assembly drawing. First is exploded assembly drawing. Yeah, the parts are spreadly displayed, but they are aligned according to their assembly position and the sequence. Yeah, exploded view is the part you become the component you explode one by one. Yeah. Another is general assembly drawing. Yeah, all the parts are drawn in their working position. Third is detailed assembly drawing. All the parts are drawn their working drawing position with a completed dimension. Yeah. Then we focus on that one. Number 2. Okay. This we call exploded. Yeah. Exploded assemble, exploded view, yeah, pictorial representation. That is the finished product. Okay, uh, that is assemble working drawing. Yeah, that one. The second one. Okay, the first is exploded assemble. The same exploded assemble, but this one we call orthographic representation. Yeah, orthographic representation. You can choose that one or with the previously, is depend on you. Yeah, that one is vectorial. Yeah, you can set like this. Okay, you can set that one vectorial, this one the orthographic. Yeah, you can't you section with the assemble, then you can show all the part inside of the drawing. Yeah, inside of the cover. This one still general assemble. Yeah, you can give all dimension related to the machine overhead are given. Yeah, so at least you give all the information, the overall size. Let's say, for example, for this model, yeah, the height is 2 meters. Okay, the width is 840. So means you can visualize. Yeah, you can visualize about the size of your product. Okay, you can design in your factory where you can put it on the machine. Yeah, that is the height is 2 meters. Let's say with the width is almost 1 meter, 840 uh, 840 millimeters. Yeah. Okay, this one only dimension related machine operation given is tabulated form. It's not shown. Yeah, you can give the form A, X, K, W. You can give all the information. Yeah, you can give all the information. Okay, same like this. Yeah, same like this. This is an assemble. Yeah, assemble drawing or assemble drawing. Yeah? You can check here. Okay, you give all the numbers here. This represent of that. Yeah, you need to memorize this. Yeah, you need to memorize this. Yeah, what the information, this one all the information. Yeah, this one all the information. Okay, and the details. Yeah, I think you have shown this previously. Yeah, but you don't know the name of the drawing. Yeah, that is, let's say number one. Yeah, here number one is tailstock base. Let's say. Then there is a number 8. You can find the number 8 here. The name is clamp handle. Yeah. There is SAE 111. That is the name of the drawing. That numbers are the part 1. Okay. There is a 11. Yeah. This one. Queen hex jump nut. Okay. Then the numbers. Yeah. Numbers is 2. Meaning in that drawing there is 2. Yeah, that is all the information that we need to know. Yeah, it is the same. Okay, you can put it here, you can put it at here, the list of the table. Yeah, list of the material, list of the parts. Yeah, you can put it here, you can put it in the button here, you can put it here also. That is similar. You can, it's depend on you, you can choose. Yeah, this is working drawing assemble. That is detail. Yeah, that is detail. Yeah, with the orthographic view, that is multiple view. Yeah, you can memorize this. The required information in general assembly drawing. Yeah, the first is all the parts. Yeah, drawn in their operating position. Part list or bill of material. BOM. Bill of material. Boom. Yeah, bill of material. Part list, we call the bill of the material BOM. Yeah. Uh, there is item numbers. Yeah. In the bill of material information, we have the item numbers, descriptive name, material, quantity required per unit machine. Yeah. Quantity. Okay. In the bill of material, you need this, all the information. Yeah. You need give this information. There is 4 information compulsory. Yeah. Leader line with the balloons around part numbers. Yeah. Okay. For machining and assemble operation and critical dimension related to operation of the machine. Yeah. Placing and information for this course. Assemble part, yeah, reference numbers, that is part list. Okay, you can put here in the title block. Okay, part list bill of material. Yeah, locate above or beside the title block. Fill the table from the button, but you can choose. Yeah, you can put in the top. Yeah, or on the button. That one. There is numbers, there is part name, requirement, material, or any notes. Yeah. I hope this information you have. Okay, there is sub, tensil, you need two support, you need set screw one, stainless steel, M3, hex, sock, cup, PT. That is all the information. Okay, something like this. Okay, this one from the top. Okay, you can change from here. Yeah, that is depend on you. Then it's going to up. Yeah, you can choose which one is more effective in terms of the space. Okay, this one is space is quite good. Then you can put it in the top. Yeah, in very wide. But if your space is too small, you can put from the bottom. Step to create assembly drawing. Yeah. First, analyze geometry and dimensions of all parts in the order to understand the assemble step and the overall shape of device or machine. Yeah. Second, select an appropriate view. Third is choose major parts. Yeah. For example, parts that have several parts assembled on. Fourth is draw a view of major parts, yeah, according to the selected view direction. Five is detailed view of remaining parts of their working position. Six is apply technique where relative position between adjustment parts are needed to clarify. Seven is add balloon, note, and dimension, or if any. Yeah. And eight is create bill of material. Okay. The numbers of view can be one, two, three, or more as needed, but it should be minimum. A good viewing direction is that represent all or most of the part assembled in their working position. Yeah. Example. There is a part A, there is a part B. Okay, student A. Okay, and student B. Okay, which appropriate assembly drawing? Yeah, you can identify which one is better, student A or student B. Yeah, you can choose actually. That is, student B is better. Yeah, general practice also. Yeah, the hidden line usually omitted unless they are absolutely necessary to illustrate some important features that a reader might otherwise miss. Okay, uh, in the assemble, normally no hidden line. Yeah. You can, if there is important, if there is important, yeah, that hidden line might otherwise miss information. Then you can show the hidden line. Mostly no. Yeah, mostly no. We can we can give another uh, we can give another perspective. Yeah, we can give another perspective. Okay. Uh, part A, there is a part B. Yeah, there is a A, there is a B. Yeah, that is good. Yeah, which one good? A or B? A is better. Yeah, A is better. Okay, that if the B is a poor, yeah, that is a misinformation. But however, yeah, you can detail on this in the part. Yeah, here there is a detail on this. Then no need for you to give this. Yeah. That is marking. Okay. Example hidden line, omit or not. Okay. Yeah. That is phone. Then you need to in. Okay. Okay. This one, which one is better? A or B? Fitri. Fitri. Which one better in the drawing? A or B?
A.
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 Okay, Khalid. A. That is good. Yeah. Then the A is good. Yeah. That is another. Yeah. The section planning usually need to clarify the mapping of the parts. Yeah. There is a part A, there is a part B. Okay. You have the assemble. Yeah. That is better. That one. Yeah. In the drawing, there is no color. Yeah. There is no color. That is black and white. That is you can check here. Okay. That is better if you choose. Yeah. If you choose uh uh the section. Yeah. The section view. That is the optional. I think that is better you use uh, a section because you omitted of the uh, hidden line. Do not draw the section line on the section view of the standard part. Yeah, that is the keyword. Do not draw the section line on the section view of standard part. Yeah, like a threaded fastener, washer, longitudinal cut off, solid shaft, pin, key. Yeah, no need. Okay, there is a first scalloping steel. Yeah, one required, arm steel, one required, pin steel, one required. Then how you assemble? Yeah, this is the our test and something like this. That is how the assemble. Let's say the president. That one, eh? That is section line practice. Yeah, there is A, there is a B. Yeah. Normally A is good because this part is not because you want to show that one. Otherwise, this is complicated. Yeah. Okay, this another example. Yeah, this is another example how to assemble. Yeah, this is assemble step. Okay, you have the first part. Yeah, that is a support. That is a steel, and you have that one. Okay, you can put. Okay, and there is a pin. Okay, that is assemble step. Okay, which one is good? There is a, there is a B, okay, there is a C. Yeah, there is a D. Yeah, there is a D is very good. Okay, you want to show inside it. Another example is, yeah, you have that one. There is arm steel. Then there is a pin, yeah, inside that one. So it's become like that. Yeah, if the A is very pure, this B is good, C also is very bad. Okay, leader line practice. Yeah, draw from the inside of the part to the balloon and place a fillet circle at the beginning of the line. Yeah, okay, you get the balloon. Yeah, draw oblique direction. Okay, there is a number 2. Yeah, let's say you have this. Yeah, you have 4 parts. Yeah, there is shaft, there is housing, there is a bearing, there is a cover plate to close the bearing. Yeah, then you need to assemble that one first. Yeah, that is the step. Yeah, the best step. Okay, then put it inside. Okay, then you have the cover of the bearing. Yeah, and you lock. Yeah, that cover actually prevent the bearing go outside. Yeah. Okay. Yeah. I think you understand. Yeah. If there is any question, I continue. Yeah. Assemble step. Function of each part in the machine. Design concept. Yeah. This example, support on the machine housing. Assemble step. First, install bearing to the shaft. Second, install bearing shaft to the unit housing. Third is install cover plate. Third is tighten screw. Yeah, function of the main parts. Yeah, That is how the assemble and the function of the main part. First, bearing, support of the rotating shaft. Yeah, there is a bearing. The function is support rotating. Otherwise, they make a friction between one part and another part. With the bearing, okay, that is there will less of the friction. Yeah, there is a cover, control and axial movements. Yeah, especially on the bearing. Yeah, then actually you can control the movement of the shaft too. And second is prevent bearing unit from rotation. Okay, there is a unit. Yeah, there is a bearing. Yeah, you cover. Then they prevent the rotation. Yeah, prevent the rotation of the form. Yeah, from the rotation. There is a design concept of that one. Avoid direct contact between rotating shaft and the housing as well as a cover plate by using bearing and clearance holes. Yeah, there is a clearance holes here. Okay, that is prevent the friction between the plate, between the cover with the bearing. Yeah, because bearing there is another side here. You can rotate also. Okay, this is another. Yeah, this is another concept. Okay, here the packaging. Yeah, here is casting. Here is gland. Yeah. Wrap a packing. This is assembly step. Yeah, the first. Yeah, wrap a packing to the shaft. Install start. Yeah, that is start. Yeah, here. Install start to the casing. The third is install to the gland. Yeah, gland to the ring where it hold align with the start. Yeah. So there is a start here. Then you put it inside the gland. There is a reference. Yeah, alignment with the start. Place the washer, tightening the nut. Yeah, that is the step. Okay, there is a function. First, packing. Prevent the leaking of the fluid inside to the casing. So the packing here, yeah, is protect. Yeah, the protect the leaking any medium. Yeah, any medium, especially is oil. Yeah, to prevent the leaking. So the oil is can go to outside. Yeah, yeah, prevent the leaking of the fluid inside the casing. Second, gland. Gland the pressing packing to make it radial expand and the press shaft surface. Yeah. So with you press with that one, yeah, with the gland, so the casing will expand. Yeah, yeah, move to here, and at the same time will expand to this direction. Okay, they will push here, and also on that direction. So the will clamp of the packaging. Yeah, the packaging will press the shaft. Okay, that is to prevent the leaking too. That is the concept. Yeah. Avoid the direct contact between rotating shaft in the casing as well as gland ring hole. Yeah, that is the thinking. Okay, that is another fixing part on the shaft. Yeah, this is how assemble step. The first is place the key. Yeah, place the key on the key seat. Second is the insert the part to the shaft until the surface lean again to the shoulder. Third is insert collar and the pin of retaining ring, yeah, into the groove. Okay, there is a function. First, preventing rotational movement path. Yeah. Second, pin and retaining ring. First is prevent axial movement of the parts on the shaft. That is design concept. Yeah. Retaining ring can resist lower axial force than collar per unit. Yeah. Collar and pin unit. That is the locking. Yeah. Part with the tapered and hole on the tapered shaft. Okay. The first is insert the part in the tapered end of the shaft. Yeah. You can put it insert the parts and the tapered, yeah, in the tapered shaft. Second is insert the washer. Non-standard, that one. Tightening the nut. Yeah. Washer improve the distribution tightening force of the part. Okay. Design concept, length of the tapered portion and the depth of the tapered hole required through a calculation. Yeah. This is a challenging actually, how to assemble. Yeah. How to assemble this one. There is a tool actually to assemble of uh, uh, the spring. Yeah. Part having preloaded spring assembly. Yeah. That is the spring with the in the free length. Another one is with the uh, application. Yeah. Okay, this one the case is mostly on the uh, yeah, absorber. Yeah, absorber in your car. Yeah, also in your motorbike. There is a use of this concept too. Yeah. The first insert spring into the casing. Yeah. Tightening the rod spring of the preloader and close the cap. Yeah. You need to push first. After that, you need to close. Yeah. Spring transmit force from the rod to the spring. Keep the spring in the position. Yeah. If with the preloading, the spring will be go to another side. Okay. Design concept: spring plunger has a spherical, yeah, surface contact to the cab actually. Therefore, the rod can be aligned inside to original position. Yeah. In the spring here, there is the flat surface. Yeah, the flat surface. Yeah, that's why the spring can be aligned with the original position. Another one is the mating part. Yeah, Mating part in the cat also there is a mating. Yeah. A point to consider. The first is the surface finish, tolerance and size geometry. Surface fitting means the quality of the surface is related to the level of the roughness of the surface. Yeah, that is the purpose to control accuracy the position. Yeah, and tightness between mating parts. That is the first. Second is to reduce the friction, especially for the parts most relative to other parts. Okay, so you need to that is another function, yeah, of the finishing or the quality surface. Yeah, it's not to there is a control accuracy position. Yeah, if the surface finish is not good, then I believe when the mating, yeah, when the mating, uh, the tolerance that you said will be is not acceptable, yeah, acceptable. Another one to reduce the friction. Okay, with let's say the surface finish is mirror, means you can reduce the friction between two parts. Tolerance, yeah, tolerance is total amount dimension may vary. It defined as the difference between upper and lower limit. Yeah, tolerance is the total amount dimension may vary. It is defined as difference between upper and lower limit. Yeah, you need to memorize this. The purpose is that is to control interchangeability part. Yeah, to ensure the mating part will have the desired fit. Yeah, that is the most important. Yeah. Okay. I have end of my lecture. There is any question?